We start with solving absolute value equations by graphing. So what do we need to do? We need to graph y equals 6 and y equals the absolute value of 3x minus 6. Maybe I'll change this one to green. So if you're going to solve this by graphing, you graph one side of the equation and you graph the other side of the equation separately. Where those two graphs intersect will be the solution to the equation. So we'll start with the easy one. How do you graph y equals 6? Y equals 6 is a horizontal line where all the y values are 6. How do you graph 3x minus 6 with the absolute value? So what we've learned so far with the absolute value graphs is you graph the inside first. So if I graph 3x minus 6, that would have a y-intercept of negative 6 and a slope of 3. So it would go up 3 over 1, up 3 over 1, up 3 over 1, and it would look like this. Now I'm just drawing this as a dotted line right now, because this dotted line is just 3x minus 6. What does the absolute value do to this graph? It takes whatever's negative and makes it positive, and keeps whatever's positive the same. So if I was graphing the absolute value of this, this part would stay positive, and this part where the graph is negative would get reflected up like this. So on 3x minus 6, we have 0, negative 6, but on the absolute value, we have 0, comma, positive 6. If I kept counting points, or if I had done this on grid paper, right, I'm going up 3 over 1, up 3 over 1. So this point here is at 4, comma 6. So from the graph, I can say the solution, x equals 0, and x is equal to 4. We can do a quick check to see if this works. What happens when I plug in 0 for x? 3 times 0 is 0, minus 6 is a negative 6. The absolute value of negative 6, is it equal to 6? Yes, it is. If I plug in 4, 3 times 4 is 12. 12 minus 6 is 6. Is the absolute value of 6 equal to 6? Yes, it is. Okay, questions for practice. 5A and B.